You don't have to write this down. Somebody tell me what x is? Sorry? 40? Agreed? How did you know it was 40?
That angle is like 90 degrees. 90 plus 60. And we use like 180.
Exactly. The sum of all three angles in a triangle is always 1. You should know this. 180 degrees. So to find this, you do 180 minus 50. We know this is 90, so we subtract 90. We get 40. Okay? That's something that you guys have done. How would you find that? A squared plus B squared equals C squared, right? Or the Pythagorean theorem. Okay? Where one leg squared plus the other leg squared will always equal the hypotenuse squared. So you guys have done that. Well, what if I give you this? Well, we can't use the Pythagorean theorem because we need 2 of the sides. We're finding a side, so we can't use the sum of angles as 180 degrees. So right now, we don't have the math to be able to do questions like this. Okay? If I know 2 of the angles, I can find the third one in a right triangle. If I know 2 of the sides, I can find the third side in the right triangle. We have that type of math. But we don't have this yet. Okay? We will have this type of math because it's called trigonometry. Okay? So trigonometry literally means triangle measurement. And we use it to find missing sides and angles in right triangles. Okay? Okay, so to use trigonometry, we need to be familiar with 3 words that we haven't encountered before. But before we even talk about those 3 words, we want to talk about names that we give to sides in right triangles that we haven't really done up to this point. Done some, okay? But remember, all this work we're going to do is on right triangles, okay? So here we have a right triangle. And it consists of 3 sides. And those sides are called little a, little b, and little c. It also consists of 3 angles. Okay? 2 of them are acute angles, meaning they're less than 90 degrees. And 1 is a right triangle. Meaning it measures 90 degrees. And this is nothing new. This is nothing earth-shattering or groundbreaking. Okay? Usually what we do when we label any triangles, not just right triangles, okay, is we label where the sides meet with capital letters, and those are the angles. Okay? The sides are labeled with lowercase letters. There is a relationship between the capital letters and the lowercase letters. Like if I drew an arrow from where angle B is, I would get side little b. If I drew an arrow out from A, I would get side little a. And if I drew an arrow out from C, I'd get side little c. That's generally how we label. So like if I said this, what would you call this side? What letter? The X. How about this one? Y. And then this is obviously Z. Okay? Works with any letters. Okay. Now, how do we name the sides when we're using trigonometry? Well, it depends on what acute angle we're talking about. Okay? So I'm just going to draw this again here. A, B, C. That's the A. That's the C. That's the B. Okay. One of these names you're already familiar with, and that's the hypotenuse. Okay. How do we find the hypotenuse in any right triangle? Where would you locate it? Like, don't write this down, but if I gave you this, which one's the hypotenuse? How do you know that? I can't.
It's across.
It's across from the right angle. Yeah, exactly. Yeah, that's one way you can find it. So in this one, C is the hypotenuse. That name doesn't change. Even if we're talking about the other acute angle. C is the hypotenuse. Now, A and B. Well, if I draw an arrow out from A, I get little a, right? Little a is called the opposite side because it's opposite to angle A. So little a is opposite. That's the word we use for that side. Little b, the third side, is what we call adjacent, meaning it's beside angle A. So these are, we're going to be using these three words a lot. If I'm talking about angle B, this acute angle, the names of the sides change. What side is opposite now? Little b. So in this one, little b is opposite. Which means that side A, the last one, is adjacent. Hypotenuse always stays hypotenuse, no matter what angle we're talking about. But the opposite and adjacent sides change depending on the angle. So if I look at this one, which side is the hypotenuse?
Yeah.
Little y, right? We're okay? What side is opposite angle X? Little x, right? Because if we draw an arrow out, we hit little x. What side is adjacent to angle Z? Why's the hypotenuse? X, right? Because if we're talking about this, this is opposite, this is adjacent. Notice how opposite and adjacent change. It depends on which angle we're talking about. But the hypotenuse always stays the same. Okay? Don't worry, you'll get that. It'll come. Okay. So in any right triangle, there are different ratios of side lengths. And identifying these ratios depends on what acute angle we're talking about. There's all sorts of ratios. So for example, in this right triangle, which is the same as the one above, the ratio, there is a ratio of the side opposite angle A, little a, over the side adjacent to angle A, little b. So it'd be A over B. There's a ratio of the side opposite angle B to the hypotenuse. There's all sorts of different ratios. Okay? We're going to talk about 3 of them. And the first one is the length of the side opposite to an acute angle to the length of the side adjacent. If we're talking about the ratio or fraction of the side opposite to an angle over the adjacent side, that ratio is called the tangent. Other ratios are given different names that we'll see later. But we're going to focus on just this one in this example. Okay? So on the previous page with that angle, the tangent of angle A equals the side opposite angle A, which was little a, to the side adjacent angle A, which was little b. But that's a lot of words to write. So in math, we would just say tan of A equals little a over little b. That's how we do it in math. Okay. Okay. If you've got a calculator, I would like you to take the tan of 27. On most calculators, you punch the tan button, 27 equals. I think that one you have to go in reverse. You have to get 27 and 10. What do you get? 3 decimal places. Anybody?
0.01.
0.509. People get the same answer? Okay, so you're in the wrong mode. And that's important. I'm glad that happened with somebody. Yeah, okay, so we gotta switch you. Oh, how do we switch this one? Yeah. There. Here we go. So what does that mean? That means in any right triangle, where one of the acute angles is 27, okay? The side opposite 27 divide the side adjacent to 27 equals 0.509, or about 0.5. So this side divide this side, okay, A divide B will equal approximately, I'll just say 0.5. So that means this side is half the length of this side. So if this was 5, this is about 10. Because 5 divided 10 is 0.5. Okay, it doesn't matter. It doesn't matter what side legs you use, as long as this divided this is 0.5. If this was 10, this would be about 20. This was 3, this would be about 6. Notice I'm picking numbers that when I divide this by this, I get a half. Okay, that's what that means. Okay. All right, let's do some examples. All you're asked to do here in this example is find the tan of D and the tan of F. Remember, the tan of D, tan means opposite D over adjacent D. What side length is opposite D in this diagram? What side length? How do you find opposite? Draw an arrow out. What side is opposite? 3, which means what side is adjacent? Done. It's 3 over 4. That's it. What's the tan of angle F? 4 over 3. Because now with F, you got to go opposite. This time it's 4 over adjacent 3. So we have to be familiar with how to set this up before we actually find, because now we can actually find the angles. Okay. Now we can actually find the angles. So before I fill this in, let's go to this example. So we're asked to find what this angle is and what this angle is. Well, what we want to do is we want to set up our tan equation. The tan of G
What side over what side in this example? 4/5. Do you notice this is an equation? Okay. How do we solve equations? We get the unknown letter by itself. Right now, there's a 10 with this. How do I get rid of a 10 so that G is by itself? You may think divide 10, but this doesn't mean multiply. Like if I said this, how would you get rid of the square root? Square, do the opposite. If I said this, how would you get rid of the square? Square root it. How do you get rid of just a tan? Something called tan inverse. Cancel each other out. And whatever you do to one side of the equation, you got to do to the other side of the equation. So you got to do the tan inverse of this. This is where you pull out your calculator. And what you will do is you will go second tan, 4/5 equals, and round your answer to 1 decimal place. What did you get? Did you take the tan inverse yet? Shouldn't get 0.7. How come we're getting 0.2? I think we might be in the wrong mode. I think we got. It's okay. Yeah. Try it. Yeah, and then we'll 4/5. You do it. You should get them.
Yeah.
Okay. Because most calculators do it in the other way, which is a little bit easier to. So 38.6. Oh, sorry, 38.7. Okay. All right. Now let's do the same thing to find G. Yeah. No, J. What's tan J equal? 5/4, right? So how do I get J by itself? Tan inverse both sides. And if I'm a betting man, I'm thinking you're going to get 51.3. How did I know that? Because the two acute sides always add up to 90.
But you've done your first trig equation. Okay?
So we work backwards by using, I know it looks like tan to the -1, but we call it tan inverse. Okay. Let's look at another example. Here's somewhere where we can actually use trigonometry. I mean, your phones would be pretty useless without trigonometry. You would not be able to find a location on your phone without trigonometry. Okay? Because it's forming triangles between you, your satellite, and the location that you're looking for. Okay? Another area we can use trigonometry is putting solar panels on house roofs. How do we know what angle to put a solar panel at so it maximizes the sunlight that it's getting? Okay? Because if you put it flat, depending on where you are, maybe you're not maximizing the sunlight that you're getting, and you're not maximizing the power you're getting out of it. Okay? Well, it's based on the latitude of the Earth where you are. Okay? Latitude means how many degrees above the equator you are. So if you're at the equator, you're at 0 degrees. As soon as you start going north, okay, then you're at 1, 2, 3, 4, 5. Oh, keep going, keep going, keep going until you hit the North Pole. Okay, we're somewhere around what, 51 degrees above the equator, something like that. Okay. We also need to know the angle of inclination of your roof. And it's the line or line segment is, what did I say here? Yeah. The acute angle formed between a horizontal line and in this case, because we're using the roof, and the line of a roof, which is obviously usually slanted. I mean, some roofs are flat, but usually slanted. And the latitude refers to the degrees away from the equator. Okay, so we have a house in Fort Smith in the Northwest Territories. Okay, and the latitude is about 60 degrees above the equator. That's where Northwest Territories is located. Obviously, it's going to be a higher latitude than us. Okay. We see that a house, there's a horizontal line or line segment of 12 feet, and the height of the roof is 9 feet. Okay. The angle of inclination would be formed between the horizontal and the line of the roof. So that's the angle of inclination. That's what we're trying to find. So let's just call it X. This is where trig comes in handy. Because if this is the angle, like notice we've got a right triangle here. This is the angle I'm trying to find. What's the name of this side? I know it's 9 feet, but what's the name that we give it? Hypotenuse is this. Opposite, right? Which means this is the hypotenuse, which this side must be the adjacent. So we're going to use tan x, because that's the missing angle, is the opposite side, which is 9, over the adjacent side, which is 12. And you should know what to do now to get x by itself. Tan inverse both sides. And let's go to the nearest whole number. What did you get? 37 degrees. So that means that the roof of the house sits at a 37-degree angle. And yet, Fort Smith is 60 degrees above the equator. Is that a good fit for a solar panel? No, because they should be very close to each other. I mean, you could still use it, but it wouldn't be the most efficient. Okay? We would obviously need a steeper roof to get more efficiency out of a solar panel that far north. Okay? So, not the best fit for a house in Fort Smith.
Like, X needs to be like closer to the
60. Yes, that's right. Okay. Last example we'll look at. We've got a 10-foot ladder leaning against the side of a building, and its bottom of the ladder is 4 feet out from the wall. I want to find what angle is the ladder making with the ground. Well, let's draw. So here, I'm just going to draw a little roof. There's a wall, there's the ground, there's a ladder. Notice in this situation, we formed a right triangle. Well, I know some of the lengths. What's this one? 10, because that's the length of the ladder. What's this length? 4. I don't know what this length is. I'm not given this length in the question, am I? Which angle am I trying to find between the ladder and the ground? This one here, right? That's the angle between the ladder and the ground. But in order to use tan, don't I need to know opposite over adjacent? But I don't know this. Can I figure it out?
Yeah.
Oh, yeah. Let's call it X, or sorry, let's not call it X because we've already called that X. Let's call it H for height. How would I find it? Don't all jump in at once, please, it's hard to hear.
Would you go to the patient?
How would I do what? No. Right triangle, I know 2 sides.
That over. Square and rising.
You're on the right track. Yes. And that's why I said draw a right triangle. So instead of A, I'll say 4. Instead of B, I'll say H, because those are the two legs, equals 10 squared. So 16 plus H squared is equal to 100. Subtract 16 from both sides. And I get H squared is equal to 84, which means how do I find H? Square root 84. Let's go one decimal place.
I'm thinking 9.2, maybe 9.1.
Mhm.
9.2?
Now I've got it. This is 9.2 feet. Now I can use trig. What does my trig equation look like? What do I start with?
9.3 and
10. Then x. Then
equal
equals. Then,
9.2.
yes, over, good. Tan inverse both sides to get x by itself. And what do we ask? Nearest degree, so nearest whole number. Sorry,
67.
67? Can I get a second person to confirm that?
Yes.
Thank you.
Which technically, that's not a safe angle to put a ladder at. Okay? If you're going above 60 degrees, you're kind of taking a little bit of a risk.
Anyway,
So that's how we use trig to find missing angles. We're next going to talk about how we can use tan to find missing sides. And then we're going to talk about two other ratios, and that's all the trig. Okay?